some of these problems to make sure that you understand how to do them. This one actually has some stuff already in it here. Um, Penguin waddles off an iceberg in Antarctica and falls into the ocean below. If he falls for 3 seconds, that's time equals 3 right there, before hitting the water, what is his speed when he hits the water? Um, since it's a falling thing, whenever something is falling, you always know at least one thing, and that's the acceleration due to gravity is 9.81 meters per second down. Um, it asks you for the speed, but in this case, speed and velocity, same thing. So we're going to use the VAT formula, which is incredibly helpful. And then we're going to substitute in 9.81 times 3. And the answer is actually, flipping my paper over, 29.43 meters per second. Okay, that shouldn't be the more difficult part of doing this. We will go to the next problem, which might be a little bit more difficult. So same situation, so we have time equals 3 seconds, acceleration due to gravity equals 9.81 meters per second squared down. And how far indicates that we're looking for a distance. So you have to look up here at the formulas. Which one has A, T, and D in it? Well, there's only one, and it's that one. So that's got to be our formula here. So D equals A times T squared divided by 2. All right, let me slide that up a little bit for you there. Keep getting caught on my post-it note here. Okay, so let's substitute into the formula. So D equals A, which is 9.81, times T squared. Now, because a lot of times people forget that the square only goes with a 3 and you need to square the 3 first, I usually put whatever the time is in parentheses and then put the square inside of it, so that ensures that I'm going to remember to do that one first. So we got 9.81 times 3 squared divided by 2. So it's 9.81 times 9 divided by 2. And when you do that math out there, you get 44.15 meters, because we're looking for a distance and the unit for distance is meters. Okay, so take a look at this next one. So we got a ripe, juicy mango falls out of a tree and lands on the sand below. If the mango falls for 2 seconds, so time equals 2 seconds. Because it's falling, we know that the acceleration due to gravity is 9.81 meters per second squared down. How far up the tree was the fruit before it fell? So we're still looking, for this one, we're again looking for distance. So our formula, just like the very last one that we did, is AT squared divided by 2. Over here in work, we're going to say D equals 9.81 times 2 squared. And remember, I put that in parentheses so that I know that the square only goes with the 2, and I have to do that first. And we're going to divide that by 2. So you end up with 9.81 times 4 divided by 2. So that looks like it's going to be 19.62, and the unit for distance is going to be meters. Okay, notice we haven't had to put directions on any of this stuff. The very first one that we did was a speed problem, so you don't need a direction. But if you did need a direction, the direction would be the same as the acceleration, which would be down. Okay, let's flip this paper over. And let's see that you can see the top of it. What's the speed of the mango? So we knew from before that the time was 2 seconds. The acceleration due to gravity is 9.81 meters per second squared down. And we're looking for the speed, which happens to be the same as a velocity. So we could use A equals V over T, or we could do ourselves a favor and use V equals AT, the VAT formula. So because VAT and the velocity and speed are the same in this situation. So we have speed equals velocity equals 9.81, that's the acceleration, times 2. So the speed when it hits the sand is 9.81 times 2, or 19.62 meters per second. Do we need a direction? Nope, because we're asking for a speed. But if we did, the direction would be down. Okay, because that's the way it's moving. So the next one, Ima Fallon was working on a roof when a huge branch pushed her off. The roof is 15 meters from the ground. This is probably the hardest problem on the whole paper, because you're going to have to use the dreaded square root. It'll be okay though. I'm with you. Don't worry. Because somebody is falling, we have acceleration due to gravity is 9.81 meters per second squared down. Assume there's no air resistance. Calculate how long it will take her to reach the ground. So we're really looking for time. Okay, so the formula that has those three things in it is D equals A T squared divided by 2. So let's substitute into that formula. You got 15 equals 9.81 times T squared divided by 2. We're going to multiply both sides by 2 over 1 to get rid of that fraction. So that leaves us with 30 equals 9.81 T squared, because these 2's on this side go away. They divide out. So now, following just regular old algebra, we want to get the variable all by itself, so we're going to divide both sides by 9.81. When you do that, you get T squared equals 3.058. Now, to be able to figure it, we don't care what T squared is, we want to know what T is, so we're going to have to do the inverse of the squaring, which means we're going to have to do a square root of both sides. And when you do that, the answer is time equals 1.75 seconds. Hardest problem, hands down, on the paper. Not because it's any different from the regular problem solving, it's just we have to deal with the squared issue. Okay, last one. This one's much easier. So, oh, yes, much easier. John is dropping snowballs off the overpass. Don't try this at home, onto the traffic below. It takes a snowball 1.2 seconds to reach the road below. How far from the road below is John dropping the snowballs? So we're looking for distance here. We know because something's dropping, it's 9.81 meters per second squared down. So our formula that has dA and T in it is D equals A T squared divided by 2. So let's substitute in there. D equals 9.81 times 1.2. And again, remember, I'm putting it inside the parentheses because I want to make sure that I do that first. And then I have to divide it by 2. So when you do that, when you do the math, 1.2 squared, multiply that by 9.81, divide that product by 2, you get 7.063 meters. And you're saying, Ms. Bolvin, why are there so many numbers after the decimal point? Because remember, when you're rounding, it's 2 non-zero numbers. But this one's 0, so that one doesn't count. So this is a non-zero number, and that's a non-zero number. So you should be all good. Okay. So hopefully that helps clarify some of the issues that you had doing this worksheet. Thanks for joining me. Have a great day.